All right, let's jump right in. Have you ever just stopped and wondered how your mapping app, how it just gets you? You can type in something that's a total mess, super vague, or maybe even just an emoji, and somehow, boom, it knows exactly what you're after. We're going to go behind the curtain and see how your map plays digital detective to basically read your mind.
Come on, we have all been there. You're in a rush, you're starving, and you mash something like this into your phone. It's a clear typo, right? But your map doesn't even flinch. It just knows, yep, you want fast food.
Or how about something like this? New York. Seems simple enough, but what are you actually asking for? The city? The entire state of New York? The map has to figure it out and make a call. And then you've got this. No words at all, just a single emoji. But believe it or not, that is a perfectly valid search, and the system instantly translates it to, I'm looking for pizza.
So, what's the secret? How does it sift through all this human chaos to pinpoint exactly what you're looking for? It's all about figuring out your intent. Let's break down how this digital detective cracks the case every single time.
So, the very first step in the investigation is to decode the what. Before it can even think about a location, the system has to understand the basic nature of your request. What is this thing you're even searching for? And this all comes down to a really important idea called user intent. Now, this isn't just about the words you typed. It's a combination of 3 key clues: your query, your actual physical location, and the part of the map you're looking at on your screen. It needs all 3 to get the full picture.
So, to nail down the what, the system sorts your query into one of these buckets. Are you typing in a specific address? Are you looking for a famous point of interest, a POI, like the London Bridge? Or maybe a specific business, like Zola in Palo Alto? Or are you just looking for a general category, like coffee shops? Classifying your query like this is the first big break in the case. And get this, a category search doesn't even have to be in words. That simple coffee cup emoji, the system is smart enough to see that and go, they're searching for the entire category of coffee. It's like a universal language.
But here's what makes the system really clever. A good detective also knows when to drop a case. It has to recognize when a search has nothing to do with a map. If you ask for the time somewhere or some random trivia, it knows this isn't a search for a physical place and doesn't try to find it.
Okay, so the system has figured out what you're looking for. That's half the puzzle solved. But now, it needs to solve for the second giant clue: pinpointing your where. Because a great answer is useless if it's in the wrong place.
And the where really breaks down into 2 main types. On one side, you've got explicit intent. That's when you spell it out, like KFC in Philadelphia. You've told the map exactly where to look. On the other side, you've got implicit intent. The location is just implied, like when you search for nearby Starbucks. The map has to deduce the where all on its own.
Now, this is a really crucial point. With those explicit queries, it's like you're giving a direct command. It doesn't matter if you're standing in London. If you search for museums in Boston, the map is going to show you results in Boston. Your words completely override your GPS location.
But for those implicit queries, the detective needs to gather more clues from the scene. It's looking at your phone's GPS location, of course, but it's also looking at the area you have on your screen. That's called the viewport. It even considers how recently you moved that viewport. So if you just panned over to a new neighborhood, the map assumes you're probably interested in that new spot.
Okay, and now for the grand finale. The system has the what, and it's figured out the where. It's time to put it all together and deliver the perfect answer. And that means serving up the right type of results.
So take a look at these 2 results. On the surface, they seem pretty similar. One is for Soho Square, the other is 201S Monroe Street. But one is a specific place, a destination, while the other is just an address. How in the world does this system know the difference?
Here it is. This is the smoking gun. See that little field down at the bottom? Classification Park? That one little piece of data is the crucial clue. It tells the system that Soho Square isn't just a point on a map. It's a specific type of place, a POI, case closed.
Now compare that to the result for the street address. See what's missing? There's no category, and the absence of that category is just as important as its presence. It tells the system, okay, treat this as a simple coordinate, not a named destination with its own identity.
So let's just quickly recap the whole method. Step 1, analyze the query to figure out the what. Step 2, determine the location to figure out the where. And step 3, put them together to serve the correct type of result, whether it's a point of interest or just a plain old address.
When you boil it all down,
The entire process is really about this. It's about being an expert translator. It takes our messy, sometimes confusing, very human requests and transforms them into a precise instruction that a machine can understand and execute perfectly.
And that leads to one last question to think about. We're already asking our devices full questions, just like we'd talk to a person. So as our searches get even more conversational, what's the next big clue these digital detectives are going to have to learn to keep reading our minds?